So welcome to our next level, level 2 physics lesson in mechanics, acceleration. Okay, so we've looked at velocity and now we're going to look at acceleration. So what is velocity? Let's look at some definitions. So velocity, you should know by now, is essentially speed with a direction. It's a vector quantity because it has a magnitude and a direction. And acceleration is a change in velocity. Again, a vector because it involves a direction, but also a magnitude or size. So in terms of types of acceleration, there are 3 types of acceleration. There is speeding up, as we see here with the car with the green light for go, so it speeds off, that's accelerating. There's also slowing down or deceleration. Okay, so you can see the red light, so the car is going to decelerate, or negative acceleration when it reaches that red light. And finally, there is the change in direction. It becomes more important when we start to look at a bit around circular motion later in this topic. So in terms of acceleration, here is an example. So you have this grey car which is going from 0 to 30 meters per second in 10 seconds. And we also have this red sports car, my car, going from 0 to 30 meters per second in 2.5 seconds. Okay, so if you plot that velocity time graph, you will see that the red car has a steeper gradient compared to the blue car, so it has a greater positive acceleration. So this is the power of the slope. So I just mentioned there the gradient. So the slope of a displacement time graph gives you the velocity, and then the slope of the velocity time graph actually gives you the acceleration. Okay, so now we have 2 things to work with and 2 different types of graphs. So you have constant positive acceleration where the velocity is changing or speeding up at a constant rate, and you'll see that as a displacement time graph, very much like the experiment you did. You saw that exponential relationship, that curved line. And in terms of a velocity time graph, it's going to be a straight line because acceleration and the change in velocity over change in time will be a constant. Then you have the corresponding negative acceleration, which you'll see as a polynomial like that on the displacement time graph. And that means that the object is actually slowing down. And that's going to be a negative linear relationship of velocity against time. So a slope of a straight line will be negative. And that's what you'll see with the velocity time graph. So in terms of moving on, in NCEA physics, there are a number of motion variables. There is displacement, which is given as d, that's the symbol. Of course, the units are meters. The initial velocity, vi, units meters per second. The final velocity, vf, which will be meters per second. Acceleration, which we've just been introduced to, which is lowercase a, with the units of meters per second. And time is in symbols t, and its units are seconds. Okay, so we're going to be using those variables to describe the motion of an accelerating object using those 5 variables. I'll point out, though, that the variables used in NCEA physics are different slightly to those used in other curricula. So if you're doing revision and you're looking at, say, A-level or IB questions or IGCSE questions, be aware that the nomenclature or the use of those symbols is slightly different. Okay, so in terms of calculating acceleration, the equation is the final velocity minus the initial velocity, that's the change in velocity, over the change in time. Okay, so A equals VF minus VI divided by T, using those symbols on the previous slide. And the units are meters per second. And the reason why is because it's meters per second minus meters per second divided by seconds, which will therefore give the units of acceleration as meters per second. So finally, think about the units, okay? So, and also the graph, okay, so acceleration equals the final velocity minus the initial velocity over time, which is meters per second, okay, and when you think about it, the change in y over change in x is going to be meters per second divided by seconds, or meters per second, acceleration. So the gradient of a velocity time graph, therefore, using dimensional analysis, is going to be the acceleration.